Draw the line bond structure of the following molecule. So our molecule is 4R5S 4,5-diethyl octane. Sorry, this is supposed to stay structure. The first thing that we do is we look at the end of our molecule and we see octane. Oct means 8 carbons, and that's our parent chain. So I will go ahead and draw an 8 carbon parent chain, and I will number it 1, 2, 3, 4, 5, 6, 7, and 8. Next, I'm going to see what is attached to my chain. So it says 4,5-diethyl. An ethyl group is 2 carbons. Di means we have 2 of them, one on carbon number 4 and another on carbon number 5. So we have 2 ethyl groups, one on carbon number 4. This is what my ethyl group looks like. It's 2 carbons. You will have to memorize prefixes in organic chemistry in order to draw and name the structures correctly. And then on 5 I have another ethyl group. The only thing that is left for us to deal with is 4R5S configuration, and this is how you can do it easily. What I'm going to do is I'm going to make sure that my hydrogen, so this carbon 4 has 3 attachments. That means it has a hydrogen that is not shown because every carbon wants to have 4 bonds, and right now it has 3 bonds only. So there must be a hydrogen that is not shown. In my line bond structures, hydrogens on carbons are not shown, but I will show it in order to draw this correctly. So the way I will show this hydrogen is I will put it on a dash. This will prevent a lot of problems. If my hydrogen is on a dash, I'm going to put the group next to it, the ethyl group, on a wedge. Next, I'm going to assign priorities to my groups. I'm going to figure out whether this is R or S. If this is indeed R, I'm going to leave it alone. And if this is S, I will switch the hydrogen and the ethyl. I will switch wedge and dash. So let's go ahead and try it. When I assign priorities, I use my atomic numbers from the periodic table to assign priorities to the 4 groups that are attached to this chiral carbon. So this chiral carbon, carbon number 4, is attached to a hydrogen, a carbon, and a carbon. Right now there is no difference. The only difference is on the hydrogen, and I use periodic table and atomic number on the periodic table to assign priorities from 1 to 4, where 1 is the biggest and 4 is the smallest. Hydrogen is the smallest. I will give it number 4. Next, I continue. I have carbon, carbon, carbon. Carbon here is attached to one more carbon. Carbon here is attached to one more carbon. Carbon on the right is attached to 2 carbons. That's a difference. This carbon wins, so this group wins, and I will give it number 1. Between these 2 groups, this carbon is attached to carbon, and then the second carbon is attached to hydrogens only. But here, carbon, carbon, and then another carbon. So going this way will win 2, and this must be 3. Next, I'm going to connect 1, 2, 3, and when I connect, if it's going clockwise, this is R is to the right, that's how I remember it, and counterclockwise will be S is to the left. So when I connect my 1, 2, 3, like this, it looks like it's going clockwise, so it looks like it's R. Did I want R? Yes. So this is good to go already. I do not need to switch anything. And let me just erase all the numbers so we do not get confused here. So this is R already. Let me assign it as R, and now I can deal with my second chiral center, which is on carbon 5. I will do the same thing. I will put my hydrogen on a dash, and I am going to put my group on a wedge, and again I have to assign priorities. So This hydrogen is number 4 because this carbon is attached to carbon. And let me just erase the, oops, that was not a good erasing. Now it's better. So this chiral carbon is attached to a carbon, and a carbon, and a hydrogen. Hydrogen is the smallest. I give it number 4. Between the carbons, this carbon is attached to 2 carbons, and this carbon is attached to 1 carbon and 1 carbon. So this wins. That's my number 1. Let me get it closer to this group. Now, between these two groups, we already did it before. So carbon, carbon, no difference. Carbon, carbon, no difference. But this is attached to another carbon, and this is not. So this would be 2, and this would be 3. Next, I connect 1, 2, 3. And it looks like it's going in the clockwise direction. So it looks like it is R. Did I want R? No, I wanted S. So what am I going to do next? I will simply switch my hydrogen with my alkyl. So instead of hydrogen being on the, let me just erase this, on the dash, and my alkyl group being on the wedge, we will say the opposite. Let's switch them. Let's put hydrogen on the wedge and my alkyl group on a dash. And when we switch them, that switches our stereochemistry. And now my stereochemistry is going to be S.